In this video, we're going to discuss some more examples using the multiplication rule. Alright, so let's go ahead and get started on these examples. So we have a poll that found 45% of Americans approve of President Obama. 5 people are randomly selected. Find the probability that 5 will support President Obama. So let's go ahead and define our event first. So we'll define S to be supporting the president. Okay, and so what we're trying to find is the probability that the first person supports the president, and the second, and the third, and the fourth, and the fifth, right? So we have 5 S's basically. All right, so we can use the multiplication rule for this. Now, I do not need to be worried about using the given that the previous person chose that they support Obama. And the reason why I don't have to be concerned about that, and I'm looking at the multiplication rule, is because these people are randomly selected. So what one person says has nothing to do with what the other person says. So these are independent events. Okay, so what one person, whether or not they support the president, has nothing to do with whether or not the next person supports the president. So when I'm using the multiplication rule, I'll just write this as, just the product. I don't need to write, given that the previous person supports the president. Okay. All right, so I have to write it 5 times. 1, 2, 3, 4, 5. Right, so of course this is just the probability of supporting the president to the 5th power. All right. So let's see, the probability of supporting the president is 0.45. It's 45%. Approve of the president to the 5th power. So that would be 0.018. So if you got a random sample of 5 people, the probability that all 5 will support the president is 0.018, which is rather small, even though the probability that one person would support the president is 0.45. Probability that all 5 would support the president is much smaller, 0.018. All right, so now let's go ahead and find the probability that at least 1 out of the 5 will support the president. All right, so remember a few videos back we were talking about how the complement of at least 1 is none, right? So either 0 people support the president, 1, 2, 3, 4, 5. Right? So at least 1 would be 1 or more. So the complement to at least 1 would be none, that no one supports the president. None out of the 5. So the probability that at least 1 support of the president is equal to the probability of 1 minus the probability of no support, no S. Okay, so the probability of no support, this means that all 5 people do not support the president, right? So this would be the probability of, so not support, remember complement, you can use this bar to mean not support. If S means support, then the bar means not support. So one person does not support, and the second, and the third, and the fourth, and the 5th. All people do not support the president, all of the 5. So 1 minus, okay, so let's see. This would be, I could use the multiplication rule. I could multiply them 5 times, or I could just bring it to the 5th power. Okay, now what's the probability of not supporting the president? Well, the probability of supporting the president is 0.45. So the probability of not supporting the president would be 1 minus 0.45. Right, 1 minus the probability of S. Remember, the probability of a complement is 1 minus the probability of the event. All right, so 1 minus 0.45, so that's basically 0.55. 0.55 to the 5th power. So that's 1 minus 0.0503, which equals 0.9497. Okay, so the probability that at least one person supports the president is rather high. At least 1 out of the 5 supporting the president, it's 0.9497.